Hi, I'm Vlad, and today I'll be talking to you about the two options to do machine learning in the Azure cloud, Machine Learning Studio and the Machine Learning Service. So my purpose here being that at the end of this talk, you should have an idea of their advantages, their disadvantages, what they're good at, what they're not, and yeah, how they might fit your use case. And fingers crossed, I'll get that purpose. Before we start, I'd like to make some introductions. So I'd like you to know a bit about me, and I'd like me to know a bit about you, to get to know each other. So in short, I'm Vlad Iliescu. I come from Romania, from sunny Romania, fingers crossed. I'm a Microsoft MVP on AI, and I work at this small but badass company called StrongBytes, where we do projects, all kinds of fun projects for customers large and small. And that's all the introduction for me. One more thing. I also like my talks to be, more of a conversation than a monologue. So I'd like you to get involved. I'd like you to ask questions and basically just try to have a discussion as much as possible. You cool with that? Yeah, awesome. Okay, so first, let me get an impression. I should not do that. Let me get an impression of what you do and who you are. Can anybody raise their hands if they have any experience with machine learning? Okay, so something like 30%, 40% of the audience. Well, machine learning in Azure, cognitive service, I'm guessing that's a subset of the first scenario. Okay, machine learning studio, an even smaller subset. Okay. Well, machine learning service, I'm guessing a total of 3 people, three. Awesome. And Python. So more of you. All right, there are pirates in the room, right? Okay, and one final last questions. How many of you are not developers? So like 30% of the room. Okay, I'm part developer, part manager. So I'm going to raise my hands for both things. Okay, right. Well, now that you know a bit about me and I know a bit about you, let's find out a bit about the 2 elephants in the room. Yeah, Machine Learning Studio and Machine Learning Service. And we'll start with Studio. Right? Studio is a very visual tool. It's a drag and drop tool for doing machine learning. You can imagine it as something like Lego for machine learning. It has multiple modules. You just drag, drop, and connect them. It's really easy. It's really straightforward. You can get from an idea, from something like a glimpse in your eye, to a deployed web service in something like 10 minutes. Really easy to get started with. The disadvantage is that it's really easy to start with, but it's not as easy to manage more complex experiments. Yeah? It's not as easy to follow best practices in development. So I see it more as an experimentation tool rather than something that you can do hardcore machine learning. On the other hand, I see Machine Learning Studio service, as being something of a DevOps for machine learning. Yeah, it simplifies training your models. It simplifies deploying them, evaluating them, scaling them. Yeah, and if you know Python, if you do machine learning in Python, it allows you to use your existing skills. On the other hand, it has a steeper learning curve as opposed to Machine Learning Studio, and you kind of need to have those machine learning skills to reuse. So yeah, advantage, disadvantage. I can also be here if you want to take a picture. Okay, I'm assuming, this is not the end of the presentation. So you know a bit about them, we can just skip this and go home. What I'd like to do is, I'd like to go into a bit more detail. Yeah, and I'd like to go into a bit more detail. I thought about how to do this, and I figured, why not do a contest? Yeah, because I'm sure you're a diverse crowd. You have a lot of experiences, and I'm sure my use cases for doing machine learning are not the same as your use cases for doing machine learning. So I figured, let's take something like 5 topics on which to evaluate those those two tools. And for each of the topic, I'll show you how to implement a thing, how to train a model, how to evaluate it, how to deploy that model in both Machine Learning Studio and Machine Learning Service. And we'll have a vote. You'll vote the one you like best. How does that sound? Is it okay? Awesome. People are nodding. So I've set up a short survey. I rearranged the slides last night. I set up a short survey. It's a Microsoft Forms form. And you can, if you go to vladiliescu.net/versus, you can open it, and you can vote for whichever tool you like best, for how many times you want to. So if you really like Machine Learning Studio, you can vote for something like 500 times. No one's stopping you, but I'm sure you won't do that because you're such nice people. Nice people don't do that, right? Right? Right. Yeah. At most 10 times, please, guys. Okay. So vladiliescu.net/versus. Now I'm going to skip back because in order to showcase those capabilities, I'm also going to need a use case. And for this use case, I've selected the data set called Petfinder, hosted by Kaggle. You know Kaggle? Yeah, some people in the crowd. So for those who don't, Kaggle is a really cool community of data scientists and machine learning practitioners. They do a lot of things. They have tutorials. They teach you how to do machine learning. And most importantly, for me, they host machine learning competitions. And this is one of the competitions they're hosting, the Petfinder one. I think it ends tomorrow. So timing. And they ask you to predict how fast a pet in a shelter would get adopted. Yeah, based on whether or not it's a cat or a dog, its breed, whether or not it's crossbreed, the colors, vaccines, so on and so forth. Right, and I figured let's use this as a use case. Let's train a model and deploy that model based on this data set. By the way, who here likes cats? Why? I also liked cats until I got one, and now it lives in a different country. By the way, this is kind of how the data set looks like. Well, you shouldn't be able to read it. But it doesn't have a lot of features, so only 22 features. And it has 5,000 entries. So not a big data set. But this is just to told you my voice. Just to give you a quick idea on how this looks. Right? Okay. And now, vote your favorite. And now, this is going to be a very demo-heavy presentation. So I'm going to actually not use slides to show you the tools. I'm going to use the tools to show you the tools, because I figured that would be cooler. Right, so now I'm going to Alt-Tab to the mighty Firefox, which has opened, coincidentally, the Machine Learning Studio and a short experiment. This is how the thing looks like. Can you see it in the back? More or less. Should I zoom in? More or less. It's zoomed in, but is this better? Awesome. Well, it's beautiful, right? As I said, this is a very visual tool.
Sorry, your
yes.
Definition, how fast, not yes or no, will get a dog. Also, how fast in the day that you're...
Yes. The target is to predict how fast a pet is being adopted. Well, actually, I'm going to use the visualizing capabilities of Studio. This is the exact data set that we've seen earlier. Well, only the entire number of columns. So I'm sure this isn't exactly visible in the back. But we can see here that it has a column called adoption speed with various numbers. So if we predict an adoption speed of 0, means it's adopted in the same day as it has been posted on the Petfinder website in a shelter. If it's 1, it's in the same week. If it's 2, I think it's in the same month, and so on, and so on and so forth. Right? So are you familiar with the concepts of regression and classification? Yes? Who here isn't? Yeah, basically, regression is trying to predict a number from a continuous range, and classification is trying to put an entry into one or more two or more buckets, right? So a bucket would be adopted today, another bucket would be adopted this week, and so on and so forth, right? So we can see this as both a classification problem or as a regression problem, yeah, because we can predict a number and then just round it out. But I'm gonna treat it as a classification problem. Okay. Back to the user interface. This is an experiment. Azure ML Studio is focused on experiment. That's the main unit of work, let's say. And we can see here multiple modules. And they have modules for everything. They have modules for training algorithms, for picking an algorithm, for doing hyperparameter sweep, for example, for ingesting data, everything. Yeah, and the modules usually have one or more input ports that you can connect to other modules, and one or more output ports, right? Because each module has an input and an output. And for example, this is my, as you've seen before, this is my data set, which I've loaded into another part of the system. I'm not going to go into that right now. So I've uploaded it as a CSV. But I could have just as easily taken it from an Azure database or from a blob storage and so on and so forth, right? And it has only one output, which allows me to either download or visualize the data set, right? So let's say I want to train a model on this. Yeah, how do I go towards this? Well, first of all, I pick a model, and in my case, it's a multi-class decision forest, because I like trees. Connect this model to the train model module. Yeah. So if I wanted to pick another algorithm, I would just type here something like classification, and pick from one of the other modules. And I could have picked a decision jungle or a logistic regression, anything really. Make sense? All right. And I'm connecting this to a part of the data set using the train model module. Yeah, which gets the data set, the algorithm, and which requires a column to know what it should be trained to predict. Yeah, in this case, the adoption speed. And what we have out of this train model thing, well, we have the train model. In this case, it's a really big forest of trees. So this is an ensemble algorithm, so it has multiple trees. And yeah, it's gonna crash and burn trying to visualize them. But if it has been something like, I don't know, logistic regression or something easier, you could have seen it easily and be able to interpret what, how the algorithm works. Okay? All right. Let's take a look a bit at this split data module. Does anybody know why I'm splitting the data here? To train and evaluate the model, but why? Why don't I use the same data set for this?
You need some to validate your model, how accurate it is.
It's not correct to evaluate the same data set to train the model.
Yeah, it's not correct. Sorry? It could be overtrained. Basically, what we're trying to do now is to see how well the model generalizes to new data, how well it handles new data it hasn't seen before. So this is why I'm splitting the data set, the big training data set, into two parts. A part which I'm using to train the model, and the other part which I'm using to evaluate the trained model, right? Basically, what you just said. And I'm running this trained model to a score model module. Everything is a module here, which gives me basically the entire data set plus some new columns. Yeah, a scored label column, which is basically what it predicted the adoption speed would be, and some probabilities for classes 0, 1, 2, 3, and 4. Yeah, and this is all fine and dandy, and we can see that the adoption speed here for, which one is this? It's a cat, so it doesn't matter. We can see the adoption speed here, it's 1, and our model predicted it to be 4, because it's a cat. Yeah, so it's obviously wrong, but we don't know how wrong this is. So we would like to be able to evaluate this. And lo and behold, we have an evaluate model that helps us, well, evaluate the model. And if we look at it, we see some really nice numbers. Yeah, we see the overall accuracy, which in our case, it's pretty bad, so it's 34%. Not the greatest model ever, right? But the average accuracy is a bit better. And also, we have this confusion matrix that helps us gauge how well the prediction goes. And what's interesting here is the diagonal. So basically, these are the correct classes. And we see that we only have about 9% accuracy for same-day adoptions. So again, not the greatest model. But we'll just go with it. I'm sure it's fine. OK. Does this make sense? Any questions so far? Yes?
Did you normalize this in between, or does the model do that itself?
I haven't normalized the data. No, this model doesn't. No, I tried to make this as simple as possible. So you do have modules for normalizing data, for parameter sweeps, but I figured it wouldn't make sense to include them now. So no, the data is not normalized. Other questions? OK. OK. And basically, this allows me to see how the model is trained and optionally deploy it, right? Now, let's see how we would do this first look and feel, very basic step, in Azure ML Service. And ML Service, now one other difference, you can see that Azure ML Studio is not integrated in the Azure portal, whereas ML Service is. Yeah, so here I'm just having a very basic resource group, Service versus Studio, where I've created the machine learning service workspace, which also created some other resources, so something like a container registry, a key vault, an application insights, things that I would need for my services. Yeah, and the magic happens here in Service versus Studio AWS. Here, I have a collection of experiments. Yeah, again, experiments. In ML Studio, we have experiments. Also here, we have experiments. Only these are different. Yeah, I don't have any new button. Yeah, I cannot create an experiment. The only way to create this is, well, there are multiple ways to create this, either via command line interface or via a Python API, yeah, because they have a really cool Python API. And this is what I'm going to show you. No, I would not like Safari to control my computer. Thank you. This is what I'm going to show you here. Big enough? Should I make it larger? Yeah? I'm going to take that as yes from the people in the back. Thank you. So what I'm doing here, familiar with Jupyter notebooks? Raise your hand, please, because if you're not, oh, something like half of the room. Cool. So these are documents that also run code, basically. The simplest explanation I can come up with. And I have multiple blocks here that include the Python code that I've already run. So in order to use this, you see, I'm going to need the Azure ML SDK. And I'm using a version that I know it's so 2 weeks ago. They released a new one last week. But I don't believe in updating libraries and tools the week before presentation. So it's a really old version. Yeah, I'm using this. Then what I'm required to do is authenticate. Yeah, because I need to authenticate to the Azure cloud. And this basically, all it does is start a new window and allows me to enter my credentials there, nothing much. Then I should open a workspace. Cheers. Nothing big, I just need to write a configuration file using my subscription ID and workspace details, and it's open. And this is where the magic happens. Yeah, this is how you create a new experiment. Yeah, 2 lines of code, one of which is an import. And then this is how I run this experiment, all in code. And the beautiful part here is that this code allows me to run an experiment both on my machine or on a compute resource in the cloud. Yeah, I could just as easily spin up, I don't know, a Docker instance or an Azure compute instance and run my scripts there if they're more resource hungry. But in this case, I'm running it on my machine because, yeah, I didn't want to overcomplicate things. And I'm seeing here a lot of logs. And I can get some details from the run. And you're going to ask, OK, this is all fine and dandy, but I didn't understand anything, right? It doesn't make sense. Because the magic is here in the train py document. Yeah? This is the script that includes the code that trains the model. Yeah, you do need to learn to know a bit of scikit. Yeah, you do need to know how to train a model, how to use Python. But then all you need to do is take your existing skills, yeah, how you train a model using Python, and you can run this everywhere you want. And it just works. And it offers capabilities for logging metrics. So does this code, I'm assuming, make sense for half of the room, and for the other, it doesn't, right? About right. OK, do you want me to go through this? Yes. Sorry? Resounding yes or resounding no? Yes. Oh, damn. OK, so what I'm doing here is run a lot of imports. So importing not the modules, but the libraries I'm going to use to train the model. Yeah, I am reading the data set from the train CSV file. So instead of having a module, I'm writing a line of code and using the pandas library for this. Then I'm selecting a series of columns, yeah, of features that I'm going to use while predicting. And if you remember, I did the same in ML Studio. Yeah, I selected some columns in the data set using the select columns module. Basically, I excluded anything that wasn't numeric. Right? I'm telling it, OK, these are the columns I want you to use while predicting, and this is the column I want to use when predicting, to predict, sorry. Then I'm creating 2 sub-data sets using those columns. Of course, using the old train test split, and I'm creating thus 4 other data sets. And the training part is as easy as instantiating a new classifier, in my case, using the default hyperparameters, I know, and fitting it on the training data set. So after these 2 lines of code, I have a trained classifier that is able to predict adoption speed, most likely as bad as the one in ML Studio, most likely. Then what I'm doing is evaluate the classifier, yeah, because I'm using it to run predict over the testing data set that I've created earlier, and then run accuracy, right? Calculate the accuracy. Then all I want is to print this accuracy on the screen, but at the same time, OK, assuming nobody looks at the screen, I also want this to be logged in the ML service experiment, right? So I'm getting the context of the current run and logging it there. So this allows me to run this experiment in the cloud, unattended, and then take a look at the outputs of the experiment and see the metrics there, see what actually happened, see which model performed best, because maybe I want to train multiple models here and compare them, right? Yes? Could you repeat the first words, please?
Where does this block go to? Where do you set it up? In Azure storage or where do you set it up?
Yes, that is a good question. It's and I'll come to it just a moment. It's in the interface, and it's also used in the storage. So and as soon as this is logged, I also serialize the model and upload it also to Azure, so we can have it for further reference later on. And let's see where this is actually logged. Yeah. So if I go to the round 1 experiment, I can see here that I have several runs. Yeah, I see that some of them are completed, some of them have failed, how much they took, the accuracy that we have logged for them. I can even see, yeah, some charts with the accuracy and run number. So I can easily identify which run worked best and which run, well, didn't. Furthermore, looking at the details of a run, I can also, maybe also see the metrics such as accuracy. But looking at the outputs, I can update that pickled file. I can view the pickled file, and I can download it to examine it, right? So, as I said, you do need some coding skills. But then everything, all this management part is handled for you. Okay, yes?
I saw in the code that you use SKLearn. So
Sorry, you saw what?
part of the code is SKLearn,
Yes.
right?
Yeah.
What part of it is Azure?
Yeah. What, yeah. What's so special about sklearn? Right. Well, great question. Yeah.
Because SKLearn is an open source.
Yeah, so why? No, very good question. Everything here is classic Python. Everything except the run. Yeah? So the same code I would write if I wanted to train a model using classic Python, no Microsoft, no Azure machine learning, except the run part and the logging of the accuracy. Okay, but the magic part is here. This is the context, in setting up the context. So this is all Azure Machine Learning Service. Yeah, they help us set the context, set the machines, orchestrate those experiments. See, everything outside the training script. And you can use whatever training script you want. If you want, you can use TensorFlow. You can request a GPU machine on which to run the experiments. And ML service handles that part. This is, for me, this is the coolest thing. Yeah, because it gives you the glue with which to create those experiments. Other questions so far? Was that a raised hand or just, no? Okay. I think this would be a good time for you to vote for the first look and feel round. But if you want, you can also leave this for, I'm so nervous, for at the end. Yeah? Now, I'm going to go also to the second round, which is analyzing and preparing data. And I'm going to show you how to do this in Azure ML first. By the way, Azure ML Studio first. I've grouped all these experiments into a small project. Yeah, this is a way of grouping that ML Studio offers us. So I'm going to open round 2, close round 1. It isn't a lot, right? But what I want to showcase here is, if I want, I could just use the import data module. Just a moment. And here, I could use a large variety of data sources, right? I could use an Azure table or SQL database, on-premises, even an on-premises SQL database, anything I want. Yeah, the fact that I'm using a CSV file is my preference for this use case. Apart from this,
I didn't see ADLS. Is that not part of data source?
You-
We have ADLS source.
ADLS, well, if it's not here, I'm not sure. I do not know. I can check that for you afterwards and we'll have a talk, but I'm not sure. Never used it. Okay. Apart from this, once we've ingested the data, we can also analyze the data and run some transformations. And the cool part is, again, this visualization. I can look easily at the distribution of a column. Yeah? You see, I have 2 values here. I easily see that I have 15,000 entries and 24 columns. I can also get some statistics. Yeah, and I can do that for any of the columns. I have some nice charts. However, these charts aren't exactly correct, right? Because while we know the color is not a numeric feature, right? The color is a category. You cannot have red and green and say that red is bigger than green. Or you can, but then, well, right? But Azure ML Studio is convinced that this is a color, and we need to find a way to tell it that, it's actually not, it's a category. And this is where the edit metadata module comes in. Yeah, this allows you to select a series of columns and change some of their attributes, make them categorical or not, change their data types or not, and so on and so forth. Right? So I'm using this, and if I click visualize on its output, which is the newly transformed data set, I have a better chart. Yeah, I can see that the vast majority of pets have the color 1, whichever that means. I hope it's brown. Yeah, we can see most pets do not have a third color, which may be a good thing, I think. Yeah, and so on and so forth. Furthermore, if we have a sufficient small number of rows, which I achieve by running a partition and sample, so I'm selecting a small subset of the data set, we could also compare the columns and see how they correlate with each other. So let's see, maybe, you see, I have an option here to compare, and I can compare adoption speed with other fields, such as type, and see that cats are adopted faster than dogs, which I'm sure they deserve. Yeah, so, or we can correlate this with age. Let me just apply a logarithm. Yes? Or with the fee, whether or not it's free or not. Okay? We can also run some summary statistics. Basically, this all helps us get an idea of how the data set looks like, how the data looks like, how it's, and how it should be interpreted, right? Because a big part of machine learning is just understanding the data and knowing what you can do with it and transforming it, of course. So right now we can see here, for example, that we have no missing values for none of the fields, which is great. Missing values are not good. We also see that we have a large data set of breeds. Yeah? These are the unique values for breed 1, 176 breeds. Yeah, but since it's a categorical feature, I don't get any statistics such as the distribution, such as percentiles, which I get for numeric columns, such as age, right? I don't have that. Basically, you can use this model to get an idea of how the data looks like. And one more thing I want to show over here is that you can also create new columns or modify existing columns using SQL script. So if you want to do, I don't know, something like math operations or something like that to create new columns, you either have to write some custom Python code, because it allows you to do that, or, my favorite part, just run a select. So in my case, I wanted to add a new column called is free if the fee was 0. And I also wanted to add a new column is pure breed, because to me that's an important feature. If breed 2 is 0. Or is multicolor, if the second and third colors are 0. And I can do this easily with a SQL script. Question so far? Yes? Yeah, what am I doing? I think is the... no, it's a really good question. So in the first round, I wanted to show you the look and feel of the two tools. So that's just how you can train the simplest experiment possible. In this round, the focus is to show you how you can, some ways. It cannot be an exhaustive list. Yeah, I cannot show you all the ways. But the case here is to show you some of the ways which you can use to analyze data and to prepare it. Yeah, to add new columns or to change existing columns. That's the purpose of the round. Thanks for helping me highlight that. Yes?
The question was, when you are running these experiments multiple times, what input are you changing so that outputs are different?
Was that the question? If I'm... Well, you know, if you don't like the question, just rephrase it and then tell what you want to say. Well, I'm using the same input. No, I'm using the same input. But in this case, I honestly don't have any output. So I'm not even running a trained model. So at all the experiments, the input is the same Pathfinder dataset, the same CSV. But here, the idea is to show you how you can, I don't know, process that dataset and then new columns. But it doesn't have any other ending. Does that make sense? Does it answer the question?
Yeah, in this one, I think the question was related to last one, I guess.
Related to the last one, to round one.
So that's why you had that graph, right? Those outputs are different
Ah.
on the same inputs.
That's because you randomized the splitting of data.
Yeah, so it's about the, yes. So it's about the round one in service versus studio in ML service, right? And why do the accuracies, yeah, because I don't have the same random key. Yeah, so exactly as you said, I'm using different data sets for training and testing, and the accuracies differ because they're different samples. So I haven't changed anything else. Yes, the SQL, so for once, I can visualize it. I can save it as a new data set if I want to. So if I do want to reuse the output of my SQL transformation or of any of these transformations, right? The select columns in data set, I can also save this as a new data set and then reuse it in other experiments. Or I can visualize it and use it in this current experiment. So I'm free to do that. No, it actually, as far as I know, it stores the new data set in ML Studio. As far as I know, now that you mention it, it might run a pipeline, but I'm not sure of that, actually. Yes, I saw, yes. I will try to do that. Yeah, here I was asked, yeah, what can you do with the data set after you've created it? Well, now moving on to machine learning service. And for machine learning service, this is pretty easy. You can just run good old Python. Yeah, so you can get the same outputs using the pandas libraries. Yeah, you can look at the structure of data set. You can look at samples of the data. Yeah, using the samples. You can run quick statistics, see how many pets were from the data set were adopted in the same day or in the same week or in the same month. Yeah, you can have charts, which, I know, it require you to know a bit about the plotting libraries in Python, but which can allow you to create more powerful things. Yeah, to visualize data in ways which simply aren't accessible in ML Studio. Yeah, and you can do that from plain old Python. You can add new columns. Yeah, for example, this is how I create is pure breed column. Yeah, using a mathematical operation, just creates a new column. No need for SQL. Yeah, and you can create percentages whatever. You know, it's what I want to highlight here is that it's Python. If you know it, you can use it, and it will just work. Yeah. Other than that, there is an SDK, a data preparation SDK, which I'm not going to show now, that allows you to also create some sort of a pipeline. It allows you to ingest data from also from SQL databases, from CSVs, from Excel files, and run a series of transformations on it, as structured as steps in a pipeline. And yes, in ML Studio, right?
Yeah.
Yes. Well, let me think how to. There is. This is a really good question, actually. But no, so yes, it's a good answer. But let me just rephrase it because I think this is really important. So the question was, yeah, you can also run Python in ML Studio. Then what are we doing talking ML service versus ML Studio? You can run Python anywhere. And really good point. However, it's a bit different. So if I'm to look at the execute Python script module here, I see that, yeah, I can get something like 2 data frames. And I know, and now you'll know, that you can use one of those data frames to also import some Python scripts. But it's not really extensible. If I want to run this in using something like, well, TensorFlow, or using another package that's not installed in this environment that runs the script, it's really hard to do that. I need to create a pipenv locally and zip it, upload it to Azure ML Studio, use it there, fingers crossed it works. It's not straightforward. Plus, I have a really limited set of environments over here. So it's either Anaconda 2.0 with Python 2.7.7 or 2 versions with Anaconda 4. If I want to use anything else, I cannot. If I want to use the same script in 2 execute Python scripts, I need to write it locally, upload it to the cloud as a zip in ML Studio, and import it here every single time. So it's really unpleasant, for me at least. Yeah, exactly. Also an ML service. Yeah. So this is all you get over here. Whereas in service, you can run it wherever you want. I would if I could, but I can't. All right. Okay, so basically, as I said, this is how you would analyze data in Python. And you could use the data preparation SDK to also give you more options for ingesting the data. But since I see time is at the premium, not going to go into that. Yes, I see a raised hand. Yes. I haven't done that, but basically you have an API. I tried logging so the graphs are represented as Python plot, as matplotlib right? And you have a log image method of the run that gets a plot, and I couldn't get it to work. So it's not documented. I'm guessing I was doing something wrong. I don't know what. You could have also saved the file locally and then run log image on the saved file, which I'm guessing it would work, but I had stopped trying, throwing my heads. But the UI certainly allows for that. Yeah, so if you look at the run, the details, you have a section here for charts and images. And they actually tell you to log image, but obviously I wasn't the man to do it. But you could. You just want to try. Right? Okay. So that was it for round 2. If you'd like to cast your vote, pretty please, with sugar on top. Next is training and evaluating models. I will not go into a lot of details over here, except for loading this. Okay, so what did I do here? Well, you can't see it, so you can't see what I did here. But basically, is run the same experiment, run it through a series of transformation steps, right? Adding new columns, selecting the columns, editing the metadata, making it all work. And then run 2 train model modules. Yeah, one for a multi-class decision forest, and the other for a multi-class neural network. I'm running both of them on score model, and then both are being fed to the evaluate model module. The cool part is that this allows me to look at them and, analyze the accuracies, analyze the confusion matrix. For me, for example, the decision tree works a bit better, right? The numbers are somewhat higher on the diagonal. And this is all fine and dandy, but what if I have more than 2 projects, more than 2 algorithms? What do I do with it? Well, after a short praying session, I get to something like, and it's loading, I get to something like this. Can you see it? No? Why? So I have told you, it's more difficult to run complex things. Yeah? So I have logistic regression, I have decision jungle, and I'm training each. I have basically dual class classifiers run through a one versus all module. so that I can use them for multi-class classification here. Everyone is being fed to score module, then to evaluate model. The evaluate models are being fed to a apply SQL transformation just to get the labels. Yeah, so all I'm doing in the apply SQL transformation is set the label, the name of the algorithm, so that I know which metrics I'm looking at. And all of this gets to this glorious, glorious module, add rows. And it's all clear now, right? You can see which algorithm is the best. Can anybody see it? No, because it's terrible, right? So I have something like this. I have the algorithms, and I have their predicted classes. This information I'm getting from the evaluate model modules. But it's really hard to compare them, right? Because I have the recall for the first class and the recall for the second, and I just want a tiny, tiny number. Is all I want. Well, if I really want that tiny, tiny number, I'm going to have to write some code here, which I haven't. Yeah, so in order to summarize this, well, you can't really, unless you write some Python code. Yes?
Is it possible to function this?
To create some sort of a function, right? Yeah, if it's possible to create some sort of a function, no.
Okay.
Or I don't know of one. I don't know of one, but I don't think so. And that I know, I would like a function. I would like some way to reuse things.
Yeah.
Yes. As far as I know, we don't have one. Yes. Well, I would create two data sets for that. So basically, we have the results of two models, and they're outputted by the score model module. Then, in theory, I could apply a SQL transformation and run a join. Or I have other modules that allow me to do that. So yes, you can do that. You can see the correlation between the two outputs. All right. Okay, if I look here at the mighty round 3, well, I think you've seen this before, right? It's the same old setup code. But it seems a bit bigger now, right? There are more statistics. This is because, if I go here, it's running a new script. And all that the script does is create an array with the classifiers I want to test, right? Because this is all about testing different models and evaluating them. So all I'm doing here is create an array of classifiers, and then run the model, try to fit the classifier, calculate its accuracy, see if the accuracy is better than the best one or not, and then just log that accuracy on the model. And I'm doing that all in a single script, right? Also dumping the model so that it's uploaded automatically to the experiment. So what this does is allow me, if I were to look at the round 3 experiment, it allows me to compare the models. I have this nice chart, for example, for model and accuracy. And I can see which model yielded the best accuracy. Well, in this case, it's random forest, and it's being overlapped by the legend, live. But I can identify the best performing model on that selection of the data set. I can see how the accuracy evolved in this. And I can also, if I'm so inclined, download any of the models here. So as I said, it's not groundbreaking. You could do the same with classic Python code, but this gives you a better way to manage all that, right? Okay. Questions? Not yet. Okay. Moving on to, well, deploying and consuming models. Well, this was fun. And it will be fun. So for deploying and consuming, ML Studio is really nice. So I don't like the way I train models in ML Studio, but I really like the way I deploy services. So for example, all I need to do in order to deploy a service based on this experiment is select a certain train model module and then set up a web service. By choosing this option, it will create a web service dedicated for that particular model, yeah, that is being trained. And we can see the predictive experiment that came out of this. Yeah, it's almost the same transformations, same inputs, but with some extra modules, yeah? The web service input, yeah, because it's being deployed as a web service. The train model, the output. And if I'm to deploy this web service, I would see, well, let me show you what I would see, because I have it set right here. It would allow me to call a simple URI using that has a REST interface and get the results. So in my case, you can see I have it exposed as a simple endpoint. It does require the bearer authentication. So it's exposed as HTTPS. It has authentication. I can send a request. This is, by the way, the REST client extension in Visual Studio. And it just gets me results. And this is so nice. And if I decide to get a more Spartan look of the data, so by not asking any details, I get the same result. So by the way, input JSON looks like this. I'm sending it the column names and some data for Skittles and Benji, both of, no, Skittles is a cat. So for Benji, that is a dog. And I'm getting adoption results prediction over here. Yeah, so really nice, really straightforward, easy to do. And this is for ML Studio. ML Service, on the other hand, well, ML Service requires some more work. So you can create here a new experiment, and you can have some runs. And then after you have some runs, maybe pick a best model. And once you've picked the best model, you can decide to register it in the models section over here. Yeah, so let's say I really like this best model PKL, right? This is my best model out of the whole experiment. So if I'm running, I can register it over here as a model in the entire workspace, and I get automatic versioning. Yeah, I have more models. And based on a model, I can create a Docker image. So as we were talking earlier on with containerizing this. Yeah, I can create a Docker image that I can deploy later on. And all I need to create an image is it's a name, and yeah, what's in a name. I was hoping you would not notice because we're running out of time. Okay, I'll show you how we registered it as a model. Very perceptive, my good sir. So after all this logging, I ran the code run register model. And so it registers the model in the whole workspace. And I can also download it if I want. Yeah. In order to create an image, well, all I need here is a scoring file. And the scoring file kind of looks like this, and a conda file. Yeah, the score is this, the conda is this. They're open at the end. Yeah, so as you can see, in the scoring, what I'm doing here is load a singleton, load the model as a singleton from the disk. Yeah, and Azure ML Service allows me to use that PKL, yeah, that model that I've associated with the image, and allows me to load it here. And then plain Python code that takes a JSON input, in my case, or raw data. It doesn't have to be JSON. Parses it and runs a prediction over it. Yeah, in my case, I complicate things a little, but yeah, it works. And the conda dependencies, well, that's just scikit for me. But you can have here any dependencies your script might require. And those will be, those will be installed automatically on the Docker machine, on the Docker image. Okay? And once I have this image, in my case, I actually have it, best image for the best model, I can also create a deployment for it, right? And a deployment, while creating a deployment, I can select the machine size. I can select whether or not it runs on Azure container instances or on Azure Kubernetes, maybe. I can do all kinds of fun stuff. And I can actually call it like this. This is my, so you can actually DDoS this if you want to. This is my IP. You will notice that on the one hand, it runs on HTTP, so it's really unsecure. And it doesn't have any authentication, so you can just send whatever, it will accept it. If you want it to run on HTTPS, or if you want it to have something like bearer tokens authentication, or, well, you can't bearer tokens. You would have to have a certificate authentication. You would have to go the manual route and use a certificate. It gives you options for this, but it's not as straightforward. Yeah, it doesn't work like this by default. We have 50 more seconds. This was supposed to go over 5 rounds. I think it's going to go with 4. We can take a look at the results. I can tell you that, well, oh my God, 24 responses. Most prefer ML Studio. But before I want to leave you with this URL. By the end of the week, I'll put the resources available, the Jupyter notebooks, the experiments. I will link to them on my website, which is vladilescu.net/service versus studio. Yeah, sorry it took so long. I preferred answering your question and having a discussion with you rather than just going through bullet points. Hope it's okay. I think I should end this right now, right? Yes. I'm going to end, but do you have 1 more minute to take a look at the results? Yes. But if you don't, okay, so I'm going to rephrase this one last time. Man, last time it was 23 responses. Okay, so for look at field, most prefer ML Studio. Yeah, me too. Analyzing and preparing data, also ML Studio. That's interesting, but yeah, it's powerful. Training and evaluating models, yes, ML Service. Deploying and consuming, ML Studio. It's significantly easier, but yeah, non-functional. Really? It's you guys. I know it was you. Yeah, so how could you have voted on this since I hadn't talked about this? But anyways, ML Studio wins all over the board. Well, thank you, kind people.